It is highly unstable. It's on the verge of detonating. No, it's about to give me the opportunity to. That's the thing, it might occur tomorrow. Could happen during this broadcast, and it would shine like a second sun in the sky. The James Webb Telescope recently detected a dramatic 250% increase in the luminosity of Betelgeuse, the red giant star positioned at the shoulder of the Orion constellation. This strange behavior has sparked excitement for a rare event. Some experts speculate that this surge in brightness could signal Betelgeuse's impending supernova, but the exact timing remains unclear. Some believe it could happen any day now. Join us as we delve into the mysteries of space and explore the fascinating details of this colossal star. Betelgeuse has the potential to revolutionize our understanding of stellar evolution. While its name may not be widely recognized, you've likely admired its glow. A brilliant red star perched at Orion's shoulder, a constellation that many are familiar with. Betelgeuse's size is staggering. If placed in the center of our solar system, its outer layers would stretch all the way out to the orbit of Jupiter. This gigantic star, often visible to the naked eye, continues to amaze us. Unlike most stars, Betelgeuse is noticeable for its gradual but substantial changes in appearance over time. Due to its closeness to our galaxy, it's classified as a semi-regular variable star, meaning its brightness fluctuates periodically, progressing toward a final collapse that will result in a supernova. In recent years, Betelgeuse has captured even more attention due to unexpected brightness variations. This includes a dramatic spike in brightness observed on May 20, 2023. Enthusiasts tracking Betelgeuse through social media reported an astonishing 142% increase in brightness, followed by a more recent update indicating a 15% rise. Andrea Dupree, an astrophysicist at the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse is now the 7th brightest star in the night sky, climbing up 3 spots from its usual position at number 10. From the southern hemisphere, Betelgeuse is an unmistakable sight in the early evening sky, shining from Orion's shoulder. Dr. Sarah Webb, an astrophysicist at Swinburne University of Technology in Australia, emphasizes the star's significance. Betelgeuse provides an exceptional opportunity to observe the final stages of a massive star's life cycle, offering invaluable insight into the behavior of red giants before they explode as supernovae. When Betelgeuse eventually detonates, it could become so bright for about a week that it might cast shadows at night. This potential has both amateur astronomers and professionals eagerly awaiting the event. Heidi Morris, a scientist at Los Alamos National Laboratory and president of the Padaro Astronomers and Astronomy Club, notes that the unpredictable fluctuations in Betelgeuse's brightness have intrigued observers for centuries. Currently, Betelgeuse's brightness cycle lasts around 130 days, much shorter than its usual 400-day period. These rapid changes give astronomers a rare chance to study a star in its final stages. The unusual behavior of Betelgeuse began in 2019 after the star expelled a significant portion of its outer atmosphere. These brightness fluctuations are abnormal for Betelgeuse, leading to speculation about whether it might soon explode as a supernova. According to a study led by Dupree and researchers from Harvard and the University of California, Berkeley, it will likely take another 5 to 10 years before Betelgeuse returns to its normal 400-day brightness cycle. Since the Great Dimming event, Betelgeuse has displayed unpredictable behavior in both light emission and radial velocity. Despite this, the star remains a massive red supergiant undergoing the rapid final stages of its evolution. Once Betelgeuse exhausts its fuel, its core will collapse under its own immense weight, triggering a supernova explosion that could rival the brightness of an entire galaxy. The exact timing of this explosion remains uncertain. Dr. Grower, an associate professor of astronomy at the University of Portsmouth, points out that predicting supernova events is incredibly challenging due to the complexities of stellar evolution and the lack of detailed data from past explosions. Currently, Betelgeuse is undergoing fusion processes in its core, moving through elements such as helium, carbon, oxygen, silicon, and ultimately iron. As a red giant, it fuses helium into carbon, a process that spans thousands of years. Over time, the star will begin fusing even heavier elements until it reaches the point where fusion can no longer continue, causing the core to collapse and potentially resulting in a black hole or a neutron star. While some theorize that Betelgeuse's explosion could be imminent, historical records suggest it has been growing redder over the past 2,000 years, implying that the supernova might take a considerable amount of time to occur. NASA estimates that Betelgeuse won't explode for another 100,000 years, which is reassuring since it's unlikely to happen in our lifetime. Despite the uncertainty, Betelgeuse continues to captivate scientists, driving advancements in our understanding of stellar evolution. Dr. Sarah Webb reminds us that while we might not live to see Betelgeuse explode, its unpredictable behavior offers valuable opportunities for discovery. By monitoring Betelgeuse's fluctuations, we could uncover new insights that propel us forward in our exploration of the cosmos. It's essential to remember that when we observe Betelgeuse, we're actually looking into the past. The light that reaches us from the star is over 600 years old. It's possible that Betelgeuse may have already exploded and we just haven't seen the light yet. While this is a possibility, it's far from certain. Astronomical history is full of surprises, as illustrated by the unexpected supernova of a massive blue star in another galaxy in 1987. Before that, scientists believed that only red supergiants could go supernova, proving how quickly our understanding of the universe can evolve. Studying Betelgeuse and other massive stars deepens our knowledge of stellar phenomena. Although Betelgeuse's explosion may be a distant event, its current behavior is still intriguing. The way stars pulsate and change over time is truly remarkable, and Betelgeuse's rapid oscillations give us a rare opportunity to study this phenomenon firsthand. Despite being far brighter than expected for a star of its type, Betelgeuse may eventually return to its regular 400-day cycle, though it seems to be struggling to do so. Recent observations suggest that the star may be nearing the end of its core carbon-burning phase, transitioning toward the creation of heavier elements like oxygen and magnesium. If this is indeed the case, experts predict that a core collapse could occur soon, leading to a supernova in just a few tens of years. However, determining the exact stage of Betelgeuse's evolution remains a challenge, and there is still much we don't understand. While the prospect of witnessing Betelgeuse's explosion is thrilling, the timing is unclear. The carbon fusion phase could last up to 100,000 years, and some studies proposing an imminent explosion are still awaiting publication. However, if it does happen during our lifetimes, it would be a momentous event, visible even during daylight for weeks. When the explosion happens, the first signs will be subtle but unmistakable, as neutrinos wash over Earth and high-energy photons escape from the expanding cloud of debris. Betelgeuse will gradually increase in brightness, reaching a peak of 10,000 to 100,000 times its normal luminosity within just a week. This extraordinary spectacle will astound anyone lucky enough to witness it, as the star's remnants may appear as bright as a quarter or half of the full moon. Remarkably, the explosion could be visible in broad daylight, casting dramatic shadows on Earth. The aftereffects of Betelgeuse's explosion would linger in our view for around 100 days, providing a rare opportunity for astronomers to study the remnants in detail. Fortunately, since Betelgeuse is so far away, the explosion will not pose any threat to life on Earth. Amateur astronomers with binoculars and telescopes will be able to observe the event without risk. Nevertheless, such a spectacular event would certainly generate widespread attention, possibly sparking renewed global interest in astronomy. Historically, supernovae have been interpreted as ominous signs, and Betelgeuse's demise would likely evoke strong reactions across cultures. Astronomers believe this event could also reignite interest in space exploration, bringing the cosmos back into public awareness on a global scale. Betelgeuse is not the only red supergiant in the galaxy. Other stars, like Edi Carini, might explode before it. Statistically, our galaxy should experience a supernova every 50 years, but we've gone nearly 400 years without observing one. However, remnants from past explosions show that another event is long overdue. Betelgeuse's history is filled with significant moments, including the remarkable dimming event of 2019. This unexpected drop in brightness baffled astronomers and led to speculation about an imminent supernova. Although the star's brightness eventually returned to normal in 2020, the cause of the dimming remained unclear until further observations revealed the true nature of the event. Skywatchers can easily spot Betelgeuse, and amateur astronomers have provided valuable data for scientists to gain a deeper understanding of Betelgeuse's behavior. Researchers rely on advanced observatories like Hubble. The mystery surrounding its dimming and potential explosion has captivated people worldwide, making Betelgeuse's eventual supernova one of the most anticipated astronomical events in human history. Unlike our Sun, Betelgeuse is a much more massive star with a shorter lifespan. Eventually, it will transform into either a neutron star or a black hole, depending on what remains after the explosion. However, experts caution against rushing to conclusions about an imminent supernova. More likely causes for the dimming, such as convective cell activity or dust clouds, may be responsible. Observations using the Very Large Telescope in Chile, led by astrophysicist Miguel Minaru, revealed that a dust cloud formed in the southern part of Betelgeuse in late 2019. The cloud, caused by an eruption on the star's surface, likely contributed to the dimming. This outburst expelled more mass than typical solar mass ejections, providing a glimpse into the star's tumultuous activity. The eruption likely stemmed from gas plumes pushing through the star's surface due to its pulsation cycle. While the specific causes remain unclear, the event provided an unprecedented opportunity to study Betelgeuse's internal processes. Minaru's team performed over 10,000 simulations, all of which supported the dust cloud theory. Their findings help explain the star's behavior and illuminate its transition toward a supernova. Despite the mysteries still surrounding Betelgeuse, continued observation and research will help us better understand the forces at play. The star's periodic fluctuations in brightness remain an exciting area of study for astronomers worldwide. While Betelgeuse may eventually explode as a supernova, it's clear that it will continue to captivate humanity for generations to come.